Space, it's a vast and mysterious place. Humans have always looked up at the stars and wondered what was out there. Are we alone? Are there other planets like Earth? Could we live on them? For centuries, these questions were just dreams, but now, we are on the verge of answering them. We are sending probes to distant planets and moons. We are building telescopes that can see billions of light years away. The possibility of life beyond Earth is no longer just science fiction. It's a real scientific possibility. And it's a possibility that we are getting closer to exploring. Of all the planets in our solar system, Mars is the most similar to Earth. It has a day that is almost the same length as ours. It has seasons, polar ice caps, and even evidence of ancient rivers and lakes. These similarities make Mars the most likely candidate for human colonization. But living on Mars would be incredibly challenging. We would need to find ways to overcome the harsh Martian environment. We would need to create a self-sustaining habitat, and we would need to develop technologies that would allow us to survive and thrive on a new world. The first challenge we face on Mars is the atmosphere. It's very thin, about 1% the density of Earth's atmosphere. And it's mostly carbon dioxide, which is poisonous to humans. This means we couldn't breathe on Mars without special equipment. We would need to wear spacesuits or live in pressurized habitats with life support systems. These systems would need to filter out carbon dioxide and generate breathable oxygen. Scientists are working on ways to extract oxygen from Martian resources. One idea is to use Martian ice, which contains frozen water. By splitting water molecules, we can get the oxygen we need to breathe. Another challenge is radiation. Mars has a very weak magnetic field, which means it doesn't have the same protection from solar radiation as Earth. This radiation can be very dangerous to humans, causing cancer and other health problems. To protect ourselves, we would need to build radiation-shielded habitats. We could also develop special suits that offer better protection during exploration. Some scientists believe we could use Martian resources like regolith or Martian soil to create radiation shielding. By building habitats underground or covering them with a thick layer of regolith, we could significantly reduce radiation exposure. Section 5. Gravity's grip, a lighter step. Mars's gravity is about 38% that of Earth's. This significant difference means that if you weigh 100 kilograms on Earth, you would only weigh 38 kilograms on Mars. The reduced gravitational pull has profound implications for how we move and live on the red planet. This means you would feel much lighter on Mars. Everyday activities like walking, running, and jumping would be much easier. Imagine being able to leap 3 times higher than you can on Earth. The reduced gravity would make you feel almost superhuman, allowing for feats of agility and strength that are impossible back home. You could jump higher and farther. This newfound ability to make large leaps and bounds could be both exhilarating and practical, especially when navigating the rugged Martian terrain. However, this lighter step comes with its own set of challenges. But this lower gravity could also have negative effects on our bodies. Our muscles and bones, accustomed to Earth's gravity, would start to weaken over time. Without the constant pull of gravity, our bodies would not need to work as hard to support our weight, leading to muscle atrophy and bone density loss. Long-term exposure to low gravity can lead to muscle and bone loss. Astronauts on the International Space Station already experience these issues, and they have to follow rigorous exercise routines to mitigate the effects. On Mars, the problem would be similar if not more severe, due to the longer duration of missions. It can also affect our cardiovascular system. The heart, which pumps blood throughout our bodies, would not have to work as hard in a low-gravity environment. Over time, this could lead to cardiovascular deconditioning, making it difficult for astronauts to return to Earth's gravity. To counteract these effects, we would need to exercise regularly and develop special equipment that simulates Earth's gravity. This could include resistance machines, treadmills, and even suits that provide additional weight to mimic the gravitational pull of Earth. Scientists are exploring artificial gravity solutions such as rotating habitats that create centrifugal force to mimic Earth's gravity. These rotating structures could provide a more Earth-like environment, helping to maintain the health and well-being of astronauts during long missions. While this technology is still in its early stages, it could be crucial for long-duration missions and colonization efforts. As we continue to explore Mars and plan for future settlements, understanding and mitigating the effects of low gravity will be essential for the success and sustainability of human life on the red planet. Section 6. From barren land to fertile ground. Mars is a very dry and dusty planet. Its surface is covered with a fine layer of iron oxide dust, giving it a reddish appearance. The atmosphere is thin, composed mostly of carbon dioxide, and the temperatures can drop to extremely low levels. This harsh environment makes it challenging for any form of life to survive, let alone thrive. Its soil lacks the nutrients needed for plant growth. Unlike Earth's rich organic soil, Martian soil is devoid of essential elements like nitrogen, phosphorus, and potassium. These nutrients are crucial for the growth of plants, and without them, the soil remains barren and lifeless. Scientists have been studying Martian soil samples to understand its composition and find ways to enrich it. This means we couldn't just plant crops on Mars and expect them to grow. The lack of water, nutrients, and suitable atmospheric conditions would lead to failed crops. On Earth, farmers rely on fertile soil, adequate rainfall, and a balanced climate to grow their crops. On Mars, we would need to replicate these conditions artificially to ensure the survival of plants. We would need to find ways to create fertile soil and grow food in a controlled environment. This involves advanced agricultural techniques and innovative solutions. Scientists are exploring various methods to create a sustainable ecosystem on Mars. Controlled environment agriculture, where temperature, humidity, and light are regulated, could be a key to successful farming on the red planet. One solution is hydroponics, a method of growing plants without soil. In hydroponics, plants are grown in a nutrient-rich water solution, providing them with all the essential elements they need. This method is highly efficient and can be used to grow a variety of crops. Hydroponics could be an ideal solution for Mars, where soil is not suitable for traditional farming. We could also use greenhouses to create artificial environments with controlled temperature, humidity, and light. These greenhouses would protect plants from the harsh Martian climate and provide them with the necessary conditions to grow. Advanced technologies could be used to monitor and adjust the environment inside the greenhouse, ensuring optimal growth for the plants. Scientists are researching ways to enrich Martian soil and make it suitable for agriculture. This involves studying the soil's composition and experimenting with different methods to add nutrients. By understanding the unique properties of Martian soil, scientists hope to develop techniques to transform it into fertile ground. This could involve introducing microorganisms that can break down Martian rocks and release nutrients. These microorganisms play a crucial role in the soil ecosystem by decomposing organic matter and releasing essential nutrients. By introducing them to Martian soil, we could kickstart the process of creating a fertile environment for plants to grow. This research is still in its early stages, but it holds great promise for the future of agriculture on Mars. Section 7. Building a home away from home. To survive on Mars, we would need to build habitats that can protect us from the harsh environment. These habitats would need to be pressurized, heated, and shielded from radiation. They would also need to be self-sustaining, with systems for generating power, recycling water, and producing food. Three-dimensional printing could be a game-changer for building structures on Mars. Using Martian regolith as a building material, three-dimensional printers could create strong and durable habitats. This would reduce our reliance on transporting materials from Earth. Section 8. Mars, a stepping stone to the stars. Exploring and colonizing Mars is not just about escaping Earth's problems. It's about pushing the boundaries of human knowledge and ingenuity. It's about learning to live sustainably on another planet. The technologies we develop for Mars could be used to address challenges on Earth such as climate change and resource scarcity. And the lessons we learn from living on Mars could help us explore even more distant destinations in the future. Mars is not the final destination. It's a stepping stone to a future where humanity becomes a multi-planetary species. Section 9. Our future among the stars. The journey to Mars won't be easy. It will be a monumental task that requires the collective effort of scientists, engineers, and dreamers from around the globe. The challenges we face are numerous and complex, ranging from the technical difficulties of space travel to the psychological and physical toll on the astronauts who will make the journey. It will be fraught with challenges and setbacks. The harsh environment of Mars, with its dust storms and extreme temperatures, will test our resilience and ingenuity. Equipment may fail, and unexpected obstacles will arise, but each setback will be a learning opportunity, bringing us one step closer to our goal. But the human spirit of exploration is indomitable. Throughout history, we have always pushed the boundaries of what is possible. driven by a relentless curiosity and a desire to explore the unknown. From the first steps on the moon to the development of cutting-edge space technology, our achievements are a testament to our determination and ingenuity. We have overcome seemingly insurmountable obstacles before. The Apollo missions, for example, faced numerous challenges, yet they succeeded in landing humans on the moon and bringing them safely back to Earth. These historic achievements serve as a reminder that, with perseverance and innovation, we can overcome even the most daunting challenges, and we will do it again. The mission to Mars will require the same level of dedication and ingenuity. Teams of astronauts and scientists are already hard at work, preparing for the journey and developing the technology needed to make it a reality. Their efforts are paving the way for a new era of space exploration. The future of humanity lies among the stars. As we look up at the night sky, we are reminded of the vastness of the universe and the endless possibilities it holds. Our journey to Mars is just the beginning, a stepping stone to even greater adventures beyond our solar system. And Mars is our first step towards that future. Establishing a human presence on the red planet will be a monumental achievement, opening the door to further exploration and the potential for colonization. It will be a testament to our ability to adapt and thrive in new environments. By embracing the challenges and pushing the boundaries of what's possible, we can make this dream a reality. The work being done today, from developing sustainable habitats to training astronauts for the harsh conditions of Mars, is laying the foundation for a future where humans can live and work on another planet. One day, perhaps not so far in the future, we will look up at the night sky and see a shining beacon of human ingenuity on the red planet. This vision of a human presence on Mars will inspire future generations to continue exploring and pushing the boundaries of what is possible. And we will know that we are no longer confined to our pale blue dot. Our journey to Mars will mark the beginning of a new chapter in human history, one where we are no longer bound by the limitations of our home planet. We are a species capable of reaching for the stars. Our innate curiosity and drive to explore will continue to propel us forward, leading to new discoveries and the expansion of our presence in the universe. The future is bright, and it lies among the stars.